All right, this is part 2 for 8.3 of geometric sequences. So now we've talked about how to find all the ways to find arithmetic sequences, and we talked about how to find geometric sequences if I can find R in A1. And now you're going to be given a different term in the sequence in R, or just 2 random terms in the sequence. So we need to remember that formula. That was important. And it is AN is going to equal A1 times R to the n minus 1 power. Okay, A1 is the first term. R is the common ratio, what's being multiplied each time. And then n is always the number of terms. Okay, so we need to first write the rule and then find the first 6 terms. Okay, so step 1, we need to find the first term, which is A1. We need to find A1. Okay, so it gives us R is 2, and it says A4 is 12. That means n is 4, and AN will be 12. So I'm going to use this equation. I'm going to plug in these 3 things that I know, and that leaves me with A1 that I can solve for. So I get AN, which is 12, equals A1, which is what we're trying to find. We do not know it yet, times R, which is 2, to the n minus 1 power. Okay, so let's simplify this a bit. Equals A1, and that's 2 cubed, which would be times 8 there. And if I divide by 8, I get that A1 is going to be 12 divided by 8, simplifies to 3 over 2. So there's A1. There's R2. Those are the, R equals 2, sorry. Those are the 2 things we need to write the rule. So that is step 2, is write the general rule of this sequence. Okay? So that means AN equals the first term times R to the n minus 1 power. There's my rule. And then step 3 is use this rule to make a table, or to find your first 6 terms. Okay, so I draw my table. 1, 2, 3, 4, 5, 6. And I'm going to plug in n being 1 into this equation and see what I get. Well, 3 halves times 2 to the 0 power is going to be 3 halves. Then 3 halves times 2 to the first power, because 2 minus 1 is 1, gives me 3. I plug in 3, I get 6. I plug in 4, I get 12. 5, I get 24. And 6, I get 48. Now, when you list these, you do put a comma between them. They're not in a table when you actually list them. And that is your first 6 terms of your sequence. All right, let's try it one more time. Given some random term and R, this means n is going to be 5. That's what a sub means. And this means AN is 32. And it tells me that R is 2/3. So I'm going to plug that into my my geometric sequence equation formula there. AN is 32 equals A1, which is what we're trying to find. That's step 1, times R, which is 2/3 to the n minus 1 power. And this n is 5, so it's 5 minus 1. So I have 2/3 to the 4th power. And I'm going to solve that. So what might be easiest to solve for A1 is taking 32, and I got to divide by 2/3 to the 4th power. Just plug that in your calculator, see what you get, and I get 162. Okay, so I have A1, I have my R, and I can write my general rule. So AN is going to equal the first term, which is A1, times my R to the n minus 1 power, and there's my rule. Use that rule to find the first 6 terms. Okay, plug in 1 for n, 162 times 2/3 to the 1 minus 1 power, which is 0 power. I get 162. which we already said was the first term, so that it should be what you get. Plug in 2 for n, 108 is what we get. 3, I get 72. If I plug in 4, I got 48. 5, I got 32. And 6, I got 64 over 3. So there's my first terms. You'd list them with commas in between them because they are a sequence. All right, now we're going to move to number 3 and 4, which now gives us just 2 random terms in the geometric sequence. And it wants me to write the equation, the rule of, the general rule for the sequence. All right, so to do this, we write a system. So that's step 1, is write a system of equations. And we want to find R. All right, so this means n is 2, an is 12. So if I write that system out, I get 12 equals a1 times r to the 2 minus 1 power. Okay, that gives me 12 equals a1 times r to the first power, which when we have the first power, we don't need to write the power. So it's really a1 times r. The second equation says n is 5, an is negative 768. So an is negative 768. We do not know a1. We do not know r, but this says n is 5. So that simplifies a little bit to give me 768 equals a1 times r to the 4th power. All right, and what I'm going to do to find r in one of these, I'm going to take one of these equations and I'm going to solve for a1, okay? So this equation right here, I can solve for a1 just by dividing by r. So I get a1 equals 12 divided by r. All right, and I'm going to take this and I'm going to substitute it into that other equation. So negative 768 equals, and a1 we just said is 12 divided by r. So I have 12 divided by r times r to the 4th power. Okay, and that simplifies. I have an r on top and an r and 4 r's on, I have 4 r's on top and 1 r on the bottom. I can simplify this down to negative 768 equals 12 times r cubed. Remember, we subtract the powers. So it's 4 minus the 1 on the bottom. And then I want to solve for r. So I'm going to divide both sides by 12. So I get negative 64 equals r cubed. And I still want just r. To get rid of a cubed power, we take a cubed root. So we're going to take the cubed root of both sides. And we end up getting r is negative 4. So there's r. We said up here, a1 is 12 divided by r. So I can use that to find a1 by taking this and substituting it in there. So I'm going to get a1 is 12 divided by negative 4, which is negative 3. So here's a1. Here's r. Plug it in to write our general rule. So that's step 3, is write the general rule. Okay, so an is the first term, which we just said was negative 3, times r to the n minus 1 power. And that's the rule. Now, if it then asked you for the first 6 terms, do what we did on these problems and draw your table. Draw your table and find your first 6 terms. All right, number 4 here. Separated a little bit. Okay, it gives us A3 equals 20. So that means n is 3, an is 20. So 20 equals a1 times r to the 3 minus 1. Which 3 minus 1, I'm just going to erase that and say that's a 2. 3 minus 1 is 2, instead of rewriting it like I did over here. And then the second one, n is 6, an is negative 160. So I have negative 160 equals a1 times r, and it'll be 6 minus 1 power, which is 5. And I want to solve one of these equations for a1. So I'm going to take this one. I'm going to solve for a1. To do that, I divide both sides by r squared. So it's 20 divided by r squared. And I like to pick the one that has the smaller power. So when I simplify it, the r ends up on top. That just makes things easier for me. And it will for you if you do the same. Okay, so I have a1. Now I'm going to take this and I'm going to substitute it in for a1 in the second equation. So I get negative 160 equals 20 over r squared, because that's what we just said a1 equals. And then that is times r cubed. So I have 3 r's on top, I have 2 r's on the bottom. So when I simplify that, I get 20r. 3 minus 2 is 1, so it's r to the first power, which is just r. Now I'm going to solve for r by dividing by 3 by 20. I'm sorry, I don't know why I said 3. Dividing by 20. But hold on, before we go any farther, I'm sorry, that wasn't r to the 5th on the top. Or I'm sorry, it wasn't r to the 3rd. This is a 5. It looked like a 3 by the way I wrote it. So that's r to the 5th. I'm sorry, so 5 minus 2 is 3. So I have r cubed on the top. Okay, I knew something was not working there. But now I'm going to divide both sides by 20, and I get negative 8 equals r cubed. This is where you cube root. Whatever that power is, you take that root of both sides, and we end up getting r is a negative 2. All right, then I need to find a1. So I'm going to take this, and I'm going to plug it into that a1 equation here. a1 is going to equal 20 divided by a negative 2 squared, because that's what r equals, was negative 2. So 20 divided by 4, a1 is going to be 5. So there's a1, there's r2, we can write our rule. So an is going to equal that first term times r to the n minus 1 power. All right, now we're going to write a rule if you're given the graph or given a table of random terms. So with this graph, the first term, when x is 1, that means n is 1, y is 5. So an or a1 is going to be 5. That's the first term. And it wants to know, okay, well, what am I multiplying by to get to the next term here? Well, remember, it's not adding, it is multiplying this time. Well, I started at 5 and I go up to 15. Looks to me like I'm multiplying by 3. And to look at the next term, let me erase all that, kind of got a lot going on here. So from 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. So that does work to get to each term. So now we just need to write our rule. an, it's the first term times r to the n minus 1 power. Okay, and you notice it is exponential. That's how I know it's geometric, and it will use that equation, that formula. Now, number 2 gives us a table. Well, I need to figure out what am I multiplying by to get to the next term. Well, from here to here, well, it goes from negative to positive, so I'm going to multiply by a negative number, and it looks like I'm just multiplying by a negative 2. Times negative 2, times negative 2, times negative 2. Okay, well, then if I take that, this gave me the second term. Well, I want the first term, so I can just actually, instead of multiplying by negative 2, I can divide by negative 2, and I get that a1 would be 6. Okay, because the rule going from 6 to 12 would still be multiplied by negative 2. So I know a1 is 6. I know that r is a negative 2, because that's what I'm multiplying by. And I can write the rule by plugging those in. a1 times r to the n minus 1 power. All right, so those are the notes for 8.3 part 2.